Hello guys, welcome back to Java session. In this particular video, we are going to cover what is this thread synchronization, how to achieve this thread synchronization, why we use this thread synchronization, and what are the different techniques to handle this multiple threads. This is what we are going to cover in this particular video, right? Now, so here, whenever you are dealing with the threads, there are cases in multi-threaded environment. So the threads comes to a situation where multiple threads, they will try to access the same resource, right? When they are trying to access the same resource simultaneously, there may be a chance to produce the errors and unexpected results because one thread is accessing the resource. Let's say T1 thread is accessing this resource. At same point of time, T2 thread is trying to modify the value in that particular resource. Then what will happen? We will get either error or unexpected result. This is the problem with the multiple threads whenever they are trying to access the shared resource simultaneously, right? So that's what to handle this kind of problems, there is a concept called as synchronization. So what is this synchronization means? Basically, by using this, you can allow one thread at a time to access the shared resources. Let's say this is the shared resource, right? So if the T1 is accessing this resource, then we do not allow the T2 until the T1 finishes its execution by using that resource. So this is a way of holding a thread until the other thread finishes its execution. This can be achieved by using this synchronization mechanism, right? Now, I'm moving further. This is all about very simple definition for the synchronization method. So this synchronization can be achieved in two ways. One, by using mutual exclusion, and the other one is by using this inter-thread communication. These are the different ways to achieve this thread synchronization. Sir, this mutual exclusive, what it will do, it helps the other thread not to interfere while the thread is using the shared resource, right? That in the sense, this is the shared resource. This shared resource used by T1, it holds the other thread not to utilize the same resource. That in the sense, the it helps keeps the thread from interfering with one another while sharing the data. That is the main advantage with this mutual exclusive, right? This can be achieved by using different techniques. One, by using, you can make a method as synchronized method, or you can make that particular block as synchronized block, or you can use static synchronization. These are the three different approaches which we can use under the mutual exclusive. Now we will cover one by one, right? So first I will explain about the synchronization, how it will happen within the operating system. Basically, this synchronization is built in around the internal entity beta that is known as a lock, or you can say it as a monitor, right? So whenever a particular resource is used by some thread, so what will happen? We will apply the lock on that particular object, right? Whenever the thread releases its resources, then only we are going to unlock that particular resource so that the other thread will access it. This is how, by applying the lock mechanism, we are going to make that thread as a synchronized. Sorry, we will make that particular resource as synchronized. Right. This you can do by making a method as synchronized, or a block as synchronized, or you can make static synchronization. Now we will see the example for this synchronization. Yes, first understand, sir, I don't make any method as synchronized. I don't make any block as synchronized. What will happen? So first understand that. Let's make, then we will make a block as synchronized and method as synchronized. Then we will understand the static synchronization. So just I want to print the table, that is fifth table or 10th table, according to the passed parameter. I want to print the table of that particular given number, right? For the purpose, I'm writing the program. I'm taking a class. So I'm taking a print table method here. If you are passing 5, then I will print the fifth table, right? For that purpose, I'm writing the logic. This is a for loop here. 5 into 1, 5 into 2, 5 into 3. This is how I am going to print the table. Then I'm going to the try block. There I am calling the sleep method. I am holding the particular thread for that many milliseconds. Then if there is any exception in the try block, I will go to the catch block and I will handle this, right? This I am doing within the table class. So I'm closing that method and I'm closing the class. That is done. Next, I'm taking my own class, which is extending the thread class, right? Now, I'm creating object to the thread class. So my thread table, my thread one equal to, this is the class. I'm passing it as a parameter, right? So some this dot t equal to t. Now I'm calling the run method. In run method, I'm calling the printable method. So t dot printable, then we will go to the printable, then we call this method and we execute this method. This I am doing it in the my thread class. Next, sir, I don't have main method in the table and my thread. That's what I'm taking one more class, right? Here, I'm taking the test synchronization. This is my class name. Next, I'm taking main method. Now I'm creating object to the class. I'm creating only one object. You can see here, I'm creating two different threads. T1 and T2. These two threads are holding the same object. I'm passing object as parameter, right? Whenever you are calling T1.stat and T2.stat, so both threads, they are going to act upon the same object. Now, I'm not making anything as a synchronized. Let's see what will happen in this particular case. So I'm compiling this. I'm running it. You can see what is happening. Two threads, they are executing simultaneously 10, 5, 100, 5, 10, 200, 5, 15. That in the sense you passed two threads, right? So here for first time you are passing print table of 5. That is T1 is executing the printing the fifth table and T2 is printing the 100 table and both are accessing the printable method, right? First T1 accessed, then T2, then T3, then T1, then T1, T2, T1, T2. This is how the method is sharing among the two threads. So with this, what is the problem? Sir, we are not getting the proper output, right? And the user, those who are going to use it, they won't understand this. So what we need, if a thread is entered into that particular method, then that should not accessed by other thread. I want to make it. So you can, sir, out of this method, which is the important part, this is the important part. You can make that block as a synchronized, right? By using this synchronized keyword, right? Synchronized of this, that in the sense you are making this block as synchronized and I'm closing this block, right? Now save this. If you run this, observe the output. Class or interface are in unexpected. Acha, you should remove the comment. I'm compiling again. I'm making the block as a synchronized. Now you can see first T1 is executed, then T2 is executed. After finishing T1, what the T1 is doing, it is releasing the lock so that T2 can access that particular thread and T2 acquired the resource and it is applied lock on that particular object and it is executed, right? Sir, you are applying the synchronization on set of statements. Let's say here, understand this very clearly better. What we are doing, we have a method that is print table method, right? In this print table method, you have n number of n lines of statements. If you are making this method as synchronized, right, then lock will be applied to this entire method. But I don't want to do that, sir. I want to apply the lock on certain part of the method. Then you can make that block as a synchronized. This is called as block level synchronization. This is called as method level synchronization, right? Sir, which is best? Better always you should use this block level synchronization. If you are making the method as synchronized so that the other lines of other portion of the method will not be accessed by other threads, right? So whatever the important part, you can make it as now synchronized. Now, sir, how to make this method as synchronized? Better now, what I'm trying to do, I will show you here only. I want to make this method as synchronized, right? Then this doesn't require, I'm not doing the block level synchronization, correct? No, right? Save this. I'm compiling and I'm running it. So in both cases, we are getting the same output. The thing is, if whenever you apply the block level synchronization, that will be applied to few lines of the code. If you are applying the method level synchronization, the method will be blocked from rest of the threads. This is the difference between the block level synchronization and method level synchronization. Next, we have the static synchronization. Sir, what is this static synchronization? Yeah. So as of now, we've seen synchronization on non-static methods. Now, if you make any static method as synchronized, what will happen? The lock will be applied on the class instead of object. As of now, we are applying the lock on the object. Now, what I want to do, sir, I want to apply the lock on the class instead of object. Sir, why we need to do this? So the problem without static synchronization is, let's say here, suppose we have T1, T2, T3, T4. These are the four threads. T1, T2, these are the two threads which are acting on object 1. T2, T3, T4, they are acting on object 2, right? So if you are making this object as synchronized, what will happen? So we can avoid the interference of T1 and T2. So if the T1 is executing, then T2 will hold, and T2 is executing, then T1 will hold, right? Same way, if you are making object 2 as synchronized, or if you are making that method as synchronized or block as synchronized, then uh, it cannot be interference between the T3 and T4. But there may be a chance of interference between the T1 and T3 and T2 and T4, right? Because they are belongings to the threads of same class. Now, sir, I I don't want to interfere between the T1 and T3, T2 and T4. Then to resolve this problem, then we need this static synchronization. So if you are making static synchronization, then what will happen? The lock will be applied on the class level, not on the object level, right? So now we will see the example for this static synchronization. Yeah, beta. You can see I'm making this print table method as static and I'm declaring it as the synchronized, right? So the rest of the code is same. Now what I'm doing, I'm creating four threads. I'm calling all four threads at a time. You can see here, I'm creating the four different threads. Thread 1, thread 2, thread 3, thread 4, T1, T2, T3, T4, right? So these T1, T2, T3, T4, these are the four threads. I'm calling these four threads simultaneously. T1 dot start, T2 dot start, T3 dot start, T4 dot start, right? So whenever you are calling the four threads, T1 is belongs to thread 1, T2 my thread 2, T3 my thread 3, T4 my thread 4. That in the sense, these four threads belongs to four different classes. In my thread 1, I am calling the run method, right? There I am calling the print table only. I am printing the first table. In the second class, I am calling the same method with a parameter 10. I am printing 10th table. In the my thread 3, I'm calling the same method, that is 100 table I'm printing. Then 1000 table I'm printing. That in the sense T1, the parameter is 1 and it is calling the printable method only. Some T2 thread, the parameter is 10. It is also calling printable method. T3, 100. It is also calling printable. T4, 1000. That is also calling printable, right? Now, if you make a method as synchronized, right, or block as synchronized, then you can avoid the interference between the T1, T2 or T2, T3 or T3, T4. But I want to avoid the interference between the all threads. Then you make that method as static and make it as a synchronized. Then the lock will be applied on the class. So one thread is entered into that class, then other threads should have to be wait until the thread is that particular method is released by the particular thread. right? Now you can see here, I'm executing this. Now you can see I'm compiling it and I'm running it. So first T1 thread getting executed, it is printing the one table. Then 100th table is getting executed. Then 1000 table. Then 10th table. So what is happening? It is avoiding the interference between all threads. Whenever you are making a static method as synchronized, then the lock will be applied on the class instead of object. This is all about the thread synchronization, the part one, that is mutual exclusive. The other one is you can also do with the inter-thread communication. Now we will see what is this inter-thread communication.